Okay, here we have some racing data from the Australian Greyhounds racing site. It had a 30% success rate, and it had various statistics which I may put up on a web page sometime later. Um, the statistics were fundamentally sound. The way they went about it, because they obviously weren't statisticians, they didn't have the races actually comparable, although they tried. So with modifications, you can really improve it. I use simple statistical linear regression. That was all. That simple technique was all you needed to improve it. And you go down there, and it goes into it's the 0.666 is the stride of a greyhound. You minus it by the margin at the end. They have a rating of 50 times 1.55 at the end. I had a rating of 100. And I think I left the 1.55 off, but we'll look at that further when I show the formula in Excel. Anyway, we'll move on in a minute. We'll just look at the formula a bit more. Okay. Now, here is the race distance, which is the X variable, and the race time, which is the Y variable for our regression, and that's the forecast. You can see the forecasts are pretty good. We'll move on. It came from the Australian Greyhound racing site. You'll have to either data render it or get some sort of web scraper to get the data, because they don't allow you to download it as a PDF anymore, and you can't actually cut and paste. It's in a JavaScript file. It's from the Australian Greyhounds website. They may have changed it, I'm not sure. Anyway, we'll move on back to the spreadsheet in a minute. And we'll run the regression. We'll save the speed times as the Y variable. We'll use the data analysis regression tool rather than the formulas and functions regression tools. Select that as the Y function. Select the speed, the distances as the X function. So for each distance, it gives a rating of how much time changes. And we'll run it. We'll put the error plot and the fit plot. And you can see with a multiple R squared of 0.99, it's incredible fit. So it's a really good model. Distance and times in greyhounds are a really, really good fit. You would say, well, of course, but not necessarily, because over distances there could be a wide disparity, but there's a remarkable similarity, and they're very consistent. The rest is statistical output, which is really compare the value of the statistics. I can just tell you that they're all highly a high probability of the outcome. The T and the Z scores were very good. The coefficient was -2 something or other, and the other one was, and the for the intercept, and the coefficient was 0.61 to multiple decimal places, which I used for putting in the formula to scale the rating on a standard format, rather than having to take each race results previously, which isn't very accurate. You can see from the error diagram that at the edges, the very extreme long distance races and short distance races don't fit so well, but the middle distance races fit with very little error, which is to be expected because at extremes greyhounds tend to perform a bit different to normal. And here's the line fit plot. You can see how good it fits. Like in the small chart, you can't see anything. When I expand it, you'll see a few blue dots. The line is, the predicted line almost obscures the actual line, which shows it's a great fit. Okay, the charts are done. We're moving on to the data. You can see how I've downloaded from a greyhound racing handicapping site all the data needed for the formula. We have the time, speeds, margins and things. Now I'll go over to where I've applied the formula down to here. I've got the statistics there and I've tested out the formula there. And you can see it works. There's a prediction of the rating. A rating's out of 100. Rather than out of 50 with the one that was used to test it. From the racing site. Okay. Now, a cut and paste. I actually used a user-defined function in VBA to standardise the formula, so you didn't have to write it out or copy and paste all the time. You just enter the formula and enter the parameters. Where is it? Down here. There's the formula. It shows distance times margin. They're all shown clearly there. How it's set up, how it's done. It's a very simple user-defined function. I'll leave the readers, viewers who don't know how to use user-defined functions to check that out for themselves. And we'll move on to show how it's used in the race. Okay, moving on. And you can see I've cut and pasted the user-defined function down. We go down. We'll just show, I think we show where we get the data from, yeah. That's the time, that's a distance, and that's a margin behind. That's all you need for the formula. The rest is hard-coded. And we put it in, and I've dragged it down. I put one of those little micro charts which shows whether the dog's form is going up or down, and that's pretty helpful as a visualization of their overall form, and that's an average time of all of them underneath. Okay, well, I think I'll sign off there.